Satu.
Sabar. Okay. Good morning or afternoon, everyone. My name is Ken, and together with my partner, we present our research titled Enhancing LQ45 Stock Prices, Forecasting Using Hybrid LSTM GRU Networks and Indobird-based Sentiment Analysis. This work was conducted as a part of our computer science program at Bina Nusantara University, submitted to ICORIS 2026. And now let's get started. Stock. Okay, first we move to the background. Stock markets are inherently fast-moving. Exchanges process millions of transactions daily, with prices shifting rapidly, making early trend recognition critical for effective risk management. Here's the challenge. Traditional models that rely on historical price data often miss a key driver of market movement or human emotion. Fear, optimism, and media driven narratives can push prices far beyond what any technical indicator will predict. Methods like ARIMA and MACD are useful starting points, but they struggle with the volatility and news sensitivity of today's market. The solutions: researchers have increasingly turned to machine learning, particularly LSTM networks, which are better equipped to handle nonlinear market dynamics and retain memory of long term trends, something classical methods simply can't match. Moving on is the research objective and contributions. Our research was motivated by a particularly extreme scenario, that is, the COVID-19 pandemic, when prices became highly volatile and traditional models broke down entirely. This is exactly where deep learning shows its edge. We set three clear goals. First, to focus specifically on the Indonesian LQ45 index, addressing the needs of local investors. Second, merge two data streams: historical price sequences and daily sentiment scores, so the model isn't flying blind on a human behavior. And third, to combine these two, one unified tool that is more reliable for risk management than any single source approach. Moving on, model evaluation. To understand why we choose this architecture, let's trace the evolution of forecasting models. Arima gave us a a statistical foundation, solid but rigid. SVM improved on that with high dimensional feature mapping through it struggled to capture long-term trends. LSTM was a major leap towards with its memory gate solving the vanishing gradient problem and excelling at sequential data. But the key insight from the literature is this: no single model dominates in all scenarios. That's why we moved to a hybrid approach, combining LSTM's strength in capturing price patterns with GRU's efficiency for short-term dynamics and layering in sentiment as an additional signal. Research methodology. Our methodology followed four stages. First is data collection. We gathered daily OHLCV data for LQ45 stocks from trusted financial vendors paired with daily sentiment scores as a second input stream. Second, pre-processing. We handled missing values, removed outliers, and applied min-max normalization to the range of 0 and 1. Critically, normalization was done before the train test split to prevent data leakage. Third, model training. The hybrid LSTM GRU network was trained on an 80-20 data split with hyperparameters tuned via Bayesian optimization. And lastly, evaluation. We use RMSE, MAE, and MAPE as our metrics. The lower the value, the closer the prediction it is to the actual market price. On the architecture side, LSTM handles long-term dependencies through its input, forget, and output gates, while GRU reduces parameter count without sacrificing short-term responsiveness. The NLP branches powered by Indobird converts daily news and social media discussions into a daily market mood score, capturing price shifts driven by public sentiment, not just historical figures.
Now let's talk about the result and discussion. The results speak for themselves. Adding sentiment analysis reduced MAPE from 25% down to 13%. RMCE dropped from 0.0156 to 0.0131 and MAE from 0.0111 to 0.0093. Across all three metrics, the sentiment enhanced model consistently outperformed the baseline. In total, this represents a 46% overall reduction in forecasting error, a substantial improvement that confirms sentiment is not just noise, but a meaningful and quantifiable signal for price prediction. Next, so why does this work? There's three reasons for this. First, the sentiment input is high quality. Before integration, our InnoBird model was validated independently, achieving an F1 score of 0.86 with a validation loss of only 0.002. That means the market mood scores fed into the forecaster are accurate and free from overfitting. Second, the dual timescale architecture, LSTM for long memory, GRU for short-term dynamics, allows the model to track both macro trends and sudden market reactions simultaneously. Third, this result provides evidence for behavioral finance theory. Incorporating sentiment directly into the deep learning pipeline, it validates that investor bias and market noise are real, measurable drivers of price discovery. One honest caveat for stocks with limited media coverage, sentiment score can be sparse, which introduce noise on low news days. Uh, Looking at the training curves, on the left, our InnoBird model reached a stable F1 score of 0.86 by the third epoch, with both train and validation loss converging cleanly. On the right, the hybrid LSTM GRU curves show train loss and validation loss tracking closely together and declining steadily over 30 epochs, a clear sign of healthy training with no overfitting. Next, here we plot the model's prediction against the actual price over the first 200 days of the test set. The predicted curve follows the actual price movement closely, capturing not only the broad upward and down trends, but also the short-term fluctuations that sentiment spikes introduce. This qualitative result reinforces what the metrics already told us numerically. And last, to wrap up, by combining LSTM's long-term memory and GRU efficiency and Indonesian language understanding, our hybrid model achieved a 46 error reduction over the sentiment blind baseline. A MIPE of 13% brings predictive modeling close enough to real-world trading accuracy to be a practical foundation for algorithmic strategies. Looking ahead, we see two clear directions: expanding sentiment sources to include retail forums and local financial social media, and exploring temporal vision transformers to let the model dynamically weight price momentum against sentiment spikes depending on context. Thank you for your time. We're happy to present our research. Thank you.